Hey everyone, welcome back to my YouTube channel. Thanks for joining us again for Workshop Quick Takes. Last time on our channel, we took apart and then refurbished in detail the door switch cluster from a 2000 Jeep Cherokee, driver's side. Got our power windows, power lock, and power mirror controls all working shiny and smooth again. And we tried to do it in a way to show you exactly what was going on so that you can do it too. Well, on that same episode, we did alert you, don't disassemble further than here, and showed you where here was. And today we're going to show you the reason why. So, if you want to see what happens when you completely disassemble that module and try to inspect the bottom side, stick around. It's not going to go quite as smooth as you could hope. We will show you how to get it all back together again if that's what you've already done, but we'd recommend avoiding it. Come back to the workbench and let's see what's going on. You probably have some broken solder connections in that device. Could be a dirty switch also, but quite often the solder connections tend to get loose over time.
So I'll be using parts from this spare one, but later I'll show you how to modify it as a spare one if you want to completely disassemble it to look for every possible broken piece.
The gamepad style directional control for the mirror removes from the top first, and then the internal pieces can be removed second. However, the left-right flipper to select the mirror has to be removed from the inside first, and then the outside piece can be carefully removed. We really don't recommend tinkering with that one unless you have to. When we get inside, we find that this replacement unit ordered off eBay has the same problems as the one we pulled out of our Jeep. So yeah, the seller may correctly advertise it as tested. It probably worked fine on the bench. But the solder connections are already cracking. It will have the same problems when installed unless we repair it first.
The absolute minimum repair that has to be done before this will work properly again is to reflow all of these joints. The other option is to completely remove the solder off of them, get these boards off, and take a look at the bottom side.
Okay, so let's do that. You are going to have to desolder every connection along the lower connector and most of the connections along the middle connector. Desoldering braid is what we're using here. It's most accessible to amateurs. Use whatever method you like, but either way, good luck with that.
Now another thing you can do, even though it's not recommended, is get your connection good and hot. Do that, and sometimes you'll get most of it. And then you can just finish it off with soldering braid.
If this is looking agonizingly tedious, then you are starting to get the point. It took us about 45 minutes to get through these. If your familiarity with the soldering iron is not as comprehensive as ours, plan on a couple hours.
Now, if you haven't done a lot of soldering before, a desoldering project like this, which took a good 45 minutes, probably shouldn't be your first project. And later I will have to come back and make sure all these pins get straightened back out because they rotate and bend inside the thermoplastic with all that heat that I had to apply. But if you get all the solder off, you should get to the point where you can start lifting them off like this. And if you find you've got one or two that are particularly stubborn, then you may need to stop and just hit them real quick with a tap from the soldering iron to make sure that they actually pop loose, because otherwise they can start ripping pads off from the bottom side of the board as well as the top. Yeah, here's some cracking there. That's not ideal. So notice that this one here does solder through to the top side. That one there does not, and so there's an isolation area around it. And so on back and forth down here. It's good to take note of though, and also note that in the process of desoldering I ended up creating a small little runner there. You want to watch out for anything like that appearing on your board because that will cause you trouble later. And these holes, if you're careful, sometimes you can very quickly just clean them out. Other times, depending on the quality of the board, you might actually rip the hole out, but this one here I think will take it. Okay, so if all goes well, these are now pretty well prepped for when I come back and do final repairs. And I can also use the electronics parts cleaner again to get some of that extra burnt rosin off there, the flux. So looking at the bottom side of these, the switches actually look like they're in pretty good shape. I'm not seeing any cracked connectors below these. I can reflow them anyway if I need to or just want to, but I don't think I'm going to have to, except maybe one or two. That one there looks just a little bit sketch.
case it isn't obvious, the switches have larger pads and round connections that aren't as prone to breaking as the connections at the ends. The ends suffer the most flexing, and that's why they take the most damage, and why you really don't need to remove this board most likely.
Okay, just for your edification, I did get this one off with minor damage occurring to one of the ring lands, but fortunately it's not one that connects on this side. And what I've proven is there's nothing interesting on this side of the board. If you reflow these connections from the top side, you're fine. So you only need to remove this one if you want to inspect the bottom side of this board. Okay, so a closer look here. This is what happens when you do accidentally tear off and damage some of the rings that go through. Now let's look at the consequences of that. These two here attach only on the top side. If I look on the bottom side, they were isolated. So I'm not too concerned about those. I just need to get those tabs off of there so they don't short against anything else. This one here is going to be a problem because that connects to a high current position down here. So I'm going to have to run a wire through or something under here to make sure I get good connection back onto that. Then these last two over here, both of these intercept on the top side too, and the top side ring looks fine, so it should make perfectly fine contact. What I do need to do now, though, before proceeding, is get all 5 of those damaged positions taken off of there so that they're not in the way later. Overheating that more than I'd like. I'm going to back off of that one for a second, let it cool down. So yeah, there's what one of those little pieces looks like, just a little bit of a copper that was plated through the hole and now it's just messed up with solder.
If you don't clean up absolutely everything before reassembly, you'll probably regret it later.
Okay, now that you've seen what goes on with that process, some obvious recommendations are, first of all, don't ever bother removing this in order to clean it. It's not worth it. There's nothing on the bottom side you can maintain. Just getting an electrical cleaner on these contacts on top here, and then putting some fresh dielectric grease on this before you go home is probably going to do most of the work. Now on these contacts only, since they have a moving switch assembly across them and are scuffed up, you could do just a very fine sandpaper across them. Don't try to do that with any of these here. You'll probably just mess them up permanently. This here, unless for some reason you really felt you had to replace this capacitor, and it's unlikely that will ever go bad in this application, there's not much to do there either. Main thing on this one is if you can reflow this row of contacts and these 2 contacts from the top, and then of course this row of contacts, in order to solve any broken issues like we saw, then you've pretty well got it covered. And then of course clean everything up here very thoroughly with parts cleaner. Okay, so now I'm in the situation where I have to make a repair on this one last hole. Because I've ripped out the thing that goes through, I can't guarantee that I'll get a proper solder bead down into here. So here's what I'm going to do instead. The only place I can come through with a tap hole is either slightly on this side of it or slightly on this side of it, and I want to make sure I do not hit that trace. So I'm going to try for slightly on this side of, well, no, because I've got another one coming through right here. So let's do this. I'm going to take off some of the solder mask here, and I don't want to go nuts, but I do want to get it fairly far down the way here so that I have a lot of solder bonding pad. And anywhere that I'm exposing the board here, I want to make sure I get a layer of solder over this so that it doesn't come back and corrode later. Okay, so I've exposed some nice shiny copper there. And now I'm going to try and do a 1/16 bit. I'm going to try and tap a hole right there, and I want to make sure I completely miss that trace. This is a little fidgety, but it just needs a little caution. And actually what I could do is just start from inside the hole. You will break small bits this way, so how aggressive you get depends on how long they last. But now I've done what I need to do. So the next step, I'm going to give myself a piece of wire that's just a little bit longer than that, and then I can feed through.
Tinned copper bus wire would be ideal for this step, but you can see we're not using that. Worst case, if you can't find solid core wire in a size you need, go to your local hardware store, check out the cables by the foot section. If they have thermostat wire, buy a foot of that and then just strip the outer insulation jacket off and you've got what you need.
Try and clip off the exits there, just like that. And hopefully that'll hold position while I finish tucking this up here. Okay, what I've just done is given myself a high current path without touching that other terminal that just comes through, giving myself a high current path back up to the top. Now we're going to find out if all that fits back together, and I'm not sure if it will because that wire is going to take up a bunch of space right there under the connector. So it's not going to sit flush like it needs to. So what I need to do to solve that is just remove a little bit of material right in there. Okay, scraped out just enough of a channel there to try and put this back together. Also, straighten out a few of these pins along here to make sure that they go back up into their spots cleanly. Okay, looks like they all want to, except that I've not given myself quite enough clearance here. Also make sure those two go on back there. Still just not quite doing it. I'm just going to work it out a little bit more and then rejoin you in a moment. Okay, that's just about as close as a fit as we can get. So, what I'm going to do to try and help that along a bit is just heat this up a little bit of extra time and see if we can't get the solder on the terminal to help us push everything back into place. Yeah, that's pretty good. Well, there we go. In case it isn't obvious, you're not going to do this twice. The amount of damage that this board suffers completely disassembling it like that one time, you're not going to get away with doing it two. So do the best you can on one repair. Hope it works. If it doesn't, you can buy another one for about 20-25 bucks. I don't know how good a quality some of those third-party ones, and I hesitate to buy them just because of the amount of current that these connections have to handle. If they're not designed right, that's going to be a problem, but what can you do? Couple last steps to reassembly. I don't want to find any unexpected continuity between these pairs. I mean, if one of them is permanently busted and this can't be reused, that's fine, but if I've got any unexpected short circuits, it could blow things up.
Of course, determining unexpected continuity requires knowing the expected continuity. If you aren't working under a camera like we were, get out your phone or camera and take a few snaps of both sides of the board from a couple different angles. You may need those later for reference.
These two here would be the ones to be most concerned about because of that wire running around down there. Okay. Couple more steps here. Notice that these are actually metal pads, not carbonized rubber like you sometimes find. So these could spray off with a little more electrical cleaner, but we already did that. See, a little rubber dimples goes through there, another one goes through there. Lights shine up through there. That's your mirror controls.
From this point forward, the remaining reassembly is the same as when we did it the first time. Check that out on the other video.
And one last check on all these. Make sure that they're fairly even. And so that should be, in theory, one fully refurbished unit. We can wash these off and get them snapped back on.
Everyone, thanks for joining us again today. Hope you found that interesting. That's what would happen if you completely disassembled your door switch cluster. We don't recommend doing it. If you already have and caused some of the kind of damage that we showed today, hopefully you picked up a couple tips for fixing it. Otherwise, go to the video from last week, stick with that one instead. We'll see you again next time, whenever that is. Has anyone seen my phone?